All right. Greetings, everyone, and welcome to the Complexity Lounge, a meetup where we gather to talk about all things related to complexity and complex adaptive systems. I'm Jocko Selberg, and somewhere out there, enabling her constraints, is the far from equilibrium, context independent Barbara Frontera. And together we co host the lounge. Before we kick it off, just a few ground rules. We will be recording today's session, so if you do not wish to be recorded, please make sure that your camera and microphone are turned off. And after Alicia's talk, we will have a question and answer period where hopefully we'll have a nice conversation with all of you. Should you have a question or comment, you can either raise your hand, your Zoom hand, or just send your question directly to Barbara via the chat with a big Q in front, and she will probably just ask you to read it out for yourself when the time comes up. Just a reminder for everybody that the recording will be posted to Vimeo on our Complexity Lounge page in the next few days, and that is where you'll find all of our past videos from the lounge. Today, we welcome back Alicia Juarerro to help us kick off our fourth year of the Complexity Lounge. Alicia is the founder and president of Vector Analytica with a doctorate in philosophy from the University of Miami, where she is also currently a research associate. She is the author of the books Dynamic in Action and Context Changes Everything, both from MIT Press. Today, Alicia will be discussing her latest thoughts on a number of topics. And once again, rather than me attempting to summarize any of it, I think I'll just hand it over to her. So, Alicia, welcome to the lounge.
Thank you, and thank you to Jocko and Barbara and Gianni for inviting me. It's been 13 months since I was on the last time. I can't believe it. It seemed like yesterday. Thank you so much to all of you for joining. Some of you it's late and so on. So when Jocko and Barbara asked me to speak, I said, well, no, you guys have heard this before. So maybe I will just go over what briefly in just one slide or two, what we talked about the last time, and then try to focus more on governing and control constraints as opposed to context enabling constraints, the context dependent constraints. But let me just summarize what we did the last time. And if my work has been focused primarily on the idea that there are forms of causation other than efficient causation. And I think of constraints as a good enough term to handle this different kind of causality. And so, as you know, I think of context-independent constraints as those that take conditions far from equilibrium, from equiprobability. They include things like gradients, density, gravity, polarity. There's really no organization with context-independent constraints. They're just non-randomness, inhomogeneities. But then it seems to me that at some point, context-dependent constraints kick in, and these take conditions far from independence, such that coordination dynamics arise. I think that there are two kinds of context-dependent constraints, both of which take conditions away from independence. In other words, they link, they enable phenomena to interact such that an emergent phenomenon arises. Enabling constraints I think of as always bottom-up and generative. That is, they are constraints that enable emergent forms of coordination to appear, coherence, integration. I think, for example, of catalysts, positive feedback, things like timing, modules, scaffolds, people have been talking about quite a bit lately, templates, affordances. Notice that none of these are efficient causes, but yet they contribute to the creation of a phenomena, a dynamic that is different from that of the components. And then once these constraints close and the coherence forms, then it seems to me that the coordination among those enabling constraints become constitutive governing constraints that top-down stabilize, regulate, and control. So these top-down second order governing or constitutive constraints are constraints that are restrictive. See, I think enabling constraints open up possibilities, open up potential. That's why I call them generative. Whereas the constitutive governing constraints sort of stabilize, control, regulate, and in that sense, restrict the phase space. So if you have positive feedback as enabling, I think constitutive governing constraints are by and large carried out as negative feedback that ensures that the process stays within the boundary of viabilities of that coherent integration that got created. And I would say that things like regulations, rules, traditions, practices, once they are established, function as constitutive governing constraints on their practitioners, on those subject to the rules and regulations, and so on. I also want to talk a little bit today about buffers, because I think that's an interesting one people don't talk much about. Right? So in a sense, what I want to say is that constraints create complex attractors in phase space. So if you think of the traditional notion, that's not that one, that's that one. If you look at the image on the left, that's the traditional Waddington notion of a developmental or fitness landscape. And I would say that the context-independent constraints set up, if you will, the space of possibilities. And remember I said a context-independent constraint takes conditions away from equiprobability. So this dip you can think of as representing, as illustrating an inhomogeneity in the phase space. But you can think of gravity as causing that, or as density or whatever, but there's not much organization there. But if time goes from top down here, then it seems as though once you get to this point, or once you get to this point, there is a differentiation in the phase space and the possibility space that occurs that I don't think can happen through context-independent constraints by themselves. I think if all you had were context-independent constraints, inhomogeneities, in a sense, this ball would create a deep, you'd end up with a black hole at the bottom. Thing would imply that would be my image of a context-independent constraint at the limit. So it seems to me that context-dependent constraints coming at that enable interactions that persist with the environment kick in at some point back in the history of the cosmos. Is it the creation of galaxies? Is it creation of, I don't know. I think that, however, Eva Jablonska's image, which I think is a beautiful image, gives you a better sense of it. See, in a sense here you've got little ripples, so it's not an absolutely uniform pond. And so you do have certain inhomogeneities here, but all of a sudden, she illustrates it, maybe this line should go up to here or up to here, but that's okay. You've got something, a constraint that's starting to create conditions that are far from, that it's relating things to each other. Here's another one, and here's another one. And as context-dependent constraints interact with one another, what happens is that the possibility space becomes increasingly furrowed and folded. And so you get a system that is individuated, that is sui generis, that it's uniquely itself. In other words, the context-dependent constraints provide a system with its individuality, with its individuation. So I would want to say that constitutive constraints integrate, harmonize, align, organize. They coordinate interactions. They generate them, and they coordinate them, timing, scheduling. Then at some point, a governing constraint kicks in. Once again, why? Because you can't just have these furrows and folds run away with themselves. So you need some kind of governing constraint top down that maintains the coordination, that maintains the coherence, that preserves the conditions that maintain those desirable interactions. I've read somewhere, and I can't remember who said it, that it's kind of like shaving the rough edges off a jigsaw puzzle so it'll fit together more easily. That's what governing constraints do. They control, they regulate, they modulate to keep the system whole, W-H-O-L-E. There's always a danger, and that is when we talk about complex systems, we're always talking about systems that are open, meaning they exchange matter, information, energy with their environment. If you try to close off one of these systems, you try to close this thing off and keep it whole, it will simply devolve towards stasis and equilibrium, and it will die because you have made it into a closed system. So the constitutive and governing constraints are always dynamic constraints. And they're not static. This is always a metastable balancing act that I think you can visualize better when you think of, if one of these constraints pulls a little bit too hard, then another one to keep that valley, that attractor, that system whole will have to loosen up a little bit. So to me, these attractors represent the underlying constraint regime, what I decided to call the constraintome. Everybody's talking about the genome and the protein. Well, what the hell, it's a constraintome that gives a system its identity, it seems to me. So what we see on the surface are organizations, they are ecosystems, they are galaxies, they are biospheres, but these just represent the goings on of the constraints that are constantly adjusting to keep the coherence going and keep it metastable. See, now, let's stop here and look at this in a bit of more detail. If you think of the boundary conditions of a system, those are in a sense the frame of the landscape. They are the initial indentations and ultimately the edges, if you will, of a dynamical system. They are the playing field with which this system has developed, has evolved, is currently operating in. And so the furrowing and folding are the dynamical attractors that create order. And what I mean by order is, where are the walls of these attractors? How deep are the walls of these attractors? And if we know anything about complex dynamical systems, we know that these get established, created, generated in a burst of entropy. But once the system is formed, the landscape is individuated and you've got a stable structure, a stable form of order. So attractors are patterns of ordered structure. Now, warning, structure does not mean static stuff, material, things like a rock or a lamp. I think of patterns of ordered dynamics are complex systems. Ordered configurations, dynamical configurations are complex systems that hold together and persist thanks to all the interplay of the entire constraintome, all the interdependence and coordination between and among the complex independent constraints and the context dependent constraints. They constitute and stabilize this dynamic order. They give the system its identity. Thermodynamically, this means that every time you have an attractor that is formed, you have a lower rate of internal entropy production, and that's what enables it to remain itself, to keep its stable, metastable structure going despite ongoing perturbations. Again, this is not, as much as Jablonka's image is better than Waddington's and more useful and illustrative, it's not, it still gives you a sense of very static puppeteers, whereas the constraints are embedded, embodied, they're part of the landscape, they are the landscape. So they align and they entrain individuals. So the characteristics of complex systems are embodied in the characteristics of those attractors, in their valleys and their walls. Some people call the walls saddles. Some people, they used to be called separatrixes. I guess people have stopped using that. So I want to start focusing more on this sort of thing that I haven't touched on in as much detail in the previous podcasts. And I want you to start thinking of the depth of each of these valleys. Just from a heuristic point of view, from an illustration and visualization display point of view, the deeper the valley of an attractor or the chute or the whatever you want to call it, the stronger the constitutive constraints those represent. At the limit, these might be constraints that are incredibly difficult to dislodge, and therefore these are constraints that become entrenched and keep that valley whole despite pretty severe perturbations and even internal fluctuations, all right? Now, that is different from the width or the breadth of the valley, which to me represents the scope of the constitutive constraints. How many instances does this attractor embrace or span? The wider this valley, the obviously, the more flexibility the instances within that valley have to be different from one another, within the same valley, but different within one another. Some constraints are loosey-goosey. And so individuals can explore that state space and develop new behaviors, develop new phenotypes, develop new forms of life. And so the breadth of the valley also represents a greater ease of adaptation. Finally, I want you to think of deep and narrow valleys. In a valley that's not only deep, but also very narrow. It could be deep, but kind of a small a chasm represents a greater homogeneity in all the instances or all the individuals that display that behavior, that embody that attractor. In other words, if an attractor represented a type of industry, manufacturing, or services, then a very deep and narrow valley would be a type of manufacturing that doesn't allow much differences in the actual examples of manufacturing that you get in that attractor. There'd be no individual variety. And I do want to make a point that many of the same sort of thing, there's no variety at all, in my view. What I mean by variety is there has to be differences. And the difference between one valley and another, of course, is a more significant kind of difference than the difference between individuals within the same valley. But in any case, they all represent homogeneities or lack thereof, and very little variability in the behavior or type of individuals within that attractor. So despite all the strength of the attractors that enable and constitute a system, sometimes, possibly because of perturbations coming in from the environment, the attractor changed dramatically. What happens when how do you tell when attractors start losing their integrity? And the answer obviously is, and it's amazing because you see these in ecosystems, you see this in financial markets, you see this in organizations that start losing their grip with their clients. Wild oscillations. It's as if you've got one of these constraints. It's just sort of pulling like crazy, and you get the thing oscillating back and forth, up and down. Or suppose that the output of that attractor has lost touch with its context. And so it's producing very stereotypical products, or more of the same. And it does it so slowly. It doesn't respond quickly to the context. It doesn't respond appropriately to the context. Then that's an example of an attractor that is failing to hold the integrity of the system together, even as it responds to the changes in context. One example that is often given of how this might happen is maybe an attractor will lose its integrity if the speed of reproduction of one of the components becomes so incredibly dramatic, it might slip the bounds of the stabilizing overall attractor it was supposed to stay within. The governing constraint didn't do its job, and so an individual component slipped the bounds of that context. And this is a beautiful example of a cancer cell that then might become itself a focus that will attract others and become a tumor. So how do you go about identifying the source of these problems? The first thing I want to point out is that I think a constraint regime can be viewed as sedimented. I think that's true, for example, of constraint regimes having to do with language. A dictionary is sedimented metaphors. So I think that was Catherine Hale's beautiful example. Dictionary meaning is just sedimented slang or metaphors. So in a sense, once a constraint regime becomes stabilized, which you want, you cannot have governing constraints if you don't have sedimented constitutive constraints that can keep the process going. So sedimentation presupposes a stable enough environment. And I want to emphasize that stability is a good thing, right? Because that is the only way you can have governance. That's the only way you can have persistence of a system. Otherwise, it would fly away if it didn't have anything that held it together. It would fly off. It would dissipate. But there is a danger of sedimentation, and that is constitutive constraints are threatened with potential overfitting. And that is a system whose constraintome, whose overall constraint regime is perfectly in tune with the existing context and the environment. Now, some people might think, oh, that's the fittest system or organization of all. We used to think that that was the ideal of evolution. In other words, survival of the fittest, the perfectly fit to its context and its environment. We have come to understand that this kind of notion of stabilization comes from classical thermodynamics, where it's just stasis. There's no more change. And that is a very dangerous process because it will not allow room for change. In particular, it will not allow room for adaptation and evolution. And it's just a problem waiting to happen. So the idea is not to sediment constraints so excessively that they lose their capacity to keep in touch with, to respond to the environment, and therefore they're overfit, and therefore no longer fit. They're overfit, but no longer fit for purpose, if you will. So better is to make sure that the constitutive constraints that you generate with enabling constraints are constitutive constraints that support resilience, not this sedimented stasis of old-time stability. And that's why I have spoken in the past in this forum of sloppy fitness. In other words, now we understand the notion of loose fit as with context as preferable to fittest, because a loose fit with context is able to adjust easily to changes in that environment. Or creating an attractor that is a bit wider rather than very narrow and very deep automatically opens up space for that loose fitness and the possibility that a phenotype would appear that would be able to discover an area of that state space that hadn't been occupied before and that would work very nicely. So it's nice to know that the concept of fitness during Darwin's era was used more like you would use it when you talk about going to a fitting at a tailor or a seamstress. So survival of the fittest means the ones that, you know, had the best tailor or the best seamstress, who are able to, you know, take in a little bit here in the suit of, or let a little bit out there if you gain some weight, or a woman's anticipating getting pregnant, and the seamstress would decide to make the dress that way to allow a little bit of slack, if you will. So sloppy fitness is slack. It incorporates slack into the constraints. So you think of adaptation more in light of adjustments, of constraints. Again, it's all those pulleys interacting together in interdependent fashion to keep the landscape whole, if you will. So since I talk to these folks very often, we were talking just last week, and then we said, all right, so how do you identify a source of a problem when an attractor is losing its grip on the constraint? And Trent Holmes said, well, you know, if you could find an agent that straddles several layers of the organization, you know, they're kind of both inside and maybe outside, or have different perspectives. They belong to this team, but they also have a skill that belongs to another team in the same organization, different disciplines, or they understand or appreciate different functions of the same organization, or they have been both client, customer, as well as parts of the organization itself. Then these would be people who would be able to see where there is a lack of fit between those different constraints that are operating at the same time. Mark suggested, well, you know, you might look at feedback, because feedback is a enabling constraint. But what if you're looking at the wrong place for feedback. Whereas you should be looking at the most relevant one, what? That is maybe the source of the problem, or the one that is more likely to be able to repair the problem. Are you focusing too locally or too globally? Greg Broem talked about, if you look at the timing, another constraint, is that what's causing just premature convergence on a decision? Sue said something similar about shouldn't choose the first solution that comes to mind. That ends up being the least common denominator. And in attractor space, that could be thought of as a local minima, right? And Chris Matz, of course, who's into options, is, if you close off options too early, then that's what causes some of these problems, and you don't get the constraint regime being closing whole when it's supposed to happen. So then the next question becomes, and how do you influence it once you identify the source of the problem? Well, one way you can do that is you have to ask yourself, is there any way to incorporate some of the enabling constraints into the constitutive constraint regime? And Jocko and I were talking about this before the talk, and maybe there's some of this going, for example, people talk a lot about scaffolds as temporary structures. I don't like that, because I think there are scaffolds that end up being incorporated into the final structure. And for example, the flying buttresses of Gothic cathedrals end up being part of the structure itself, and yet are able to hold the thing together better. So, by adding a scaffold that maybe can get incorporated into the structure, you can strengthen an existing attractor, for example, or those nutrient lattices that are inserted when somebody breaks a bone, fractures a bone, and a lot of times those bone lattices get absorbed into the bone itself, the osseostructure, and so it becomes part of the constitutive constraint. That part of the bone ends up being stronger than the part that didn't have the scaffold to help it grow into, or templates, bone lattices that work as templates. Herbert Simon talked a lot about modules way early on, that famous example of his watchmaker example, where if one way to make sure that the attractor doesn't break down is if you can create modules along the way. I think of modules sometimes as ratchets, because what modules and scaffolds and ratchets do is they provide local and close in points of equilibrium that you can use, which, because of their location, which is a spatial constraint, point to what should come next. So modules help. They also help if in the watchmaker example, if you get interrupted in a process, if you have it modularized, then you don't have to start from scratch from the beginning. So modules along the way help. Oh, I would think those cabins in the Appalachian Trail, or sheds, or overnight, I don't know what they're called, that people, you can sort of stock up with a granola bar or two if you find. These are little enabling, supporting, scaffolding constraints that assist with maintaining an existing attractor. Now there's a danger. It's very dangerous it's very tempting to try to isolate an attractor. If I could just freeze this attractor, then I'd make sure it just stays there and stays put. But again, it's not only not easy. If you can do it at all, it will usually tend to freeze the system. So if you're managing a dynamical complex system and you're thinking of it in this sense, isolating an attractor is probably at best a very short-term solution. It's better to stabilize an attractor by, say, adding ratchets and scaffolds along the way so that it can continue along its path in the right direction with the right strength, responsive to the new and upcoming context and so on. So if you think also of sedimentation as habits, then you realize that habits are almost, habits or sediments, are sedimented constraints that help stabilize systems. You know, if I ever got into the habit of leaving my keys on the console in the front door, I would lose them less often. Yeah, sure. But on the other hand, it gets very easy to have this become entrenched, and that's what we'll be getting to next. But so making a valley deeper is a way to influence existing attractor, and scaffolds that incorporate a flying buttress into the cathedral make the valley deeper. But that's good when you're in a situation where you can exploit the landscape. You're as an organization, in the context in which you're working, you can, you know, you're probably the only person with that product, with that service, whatever. That's pretty good strategy for exploitation. But making the walls higher and deeper ultimately will stabilize those at the expense of making them harder to get over. It will be very difficult to adapt and evolve if something happens that makes it impossible for that wall to hold. So another way of influencing an existing attractor is, well, hell, make it lower. Just let's lower these stabilizing governing constraints and see whether the individuals within the earlier form can explore adjacent possibilities and discover new alternatives that we hadn't thought of before. This works better, obviously, in under conditions of exploration, not so much under conditions where exploitation will be better for the organization, for example. So what I want to then now turn to a bit is the notion that we tend to think of these walls of these attractors as made up of dirt, of soil, of bricks, of rigid, impenetrable materials. That is emphatically not so. I want you to think of things like fast and short speeds being boundaries that separate types of system from each other. So don't reify boundaries. Think of boundaries as differences in rates, in relative stability. So systems with different phase amplitudes, wave amplitudes, are different systems. They are separated by phase boundaries. Speeds make for boundaries. Differences in speed make for boundaries between systems. That is why Bateson's notion of information is a difference that makes a difference. Well, when you run across a difference in this complexity frame of mind, you have to think, ooh, there's a boundary here. What does this mean? It means I'm reaching the edge of a particular dynamic. So attractor saddles are boundaries, but they may come in the form of rate and phase differences. They're not always rigid materials. So I'd like to talk a little bit about several of these. This list is by no means exhaustive at all. But if you think of a boundary as what is allowed into the system and what stays in the system, what gets expelled from the system, that indicates that there's a boundary of inside and outside. But this might be information. These might be resources. So boundaries, in a sense, separate self from non-self. And these are very hard to tease apart when you're dealing with those intertwined constraint regimes, as that diagram of Idva Jablonska that I put up earlier. And when you add time into the process, it makes it even more difficult. So sure, rigid walls have been used as boundaries. I would want to say that's a very primitive notion of a boundary and a border. The Great Wall of China, of course, was an example, but then how long ago did anybody think that that would be a sensible type of boundary to implement, especially if you keep an open system open? Usually walls are designed to keep things closed. That's not to say that nature hasn't continued to use rigid walls. Prokaryotes, one-celled organisms without a membrane, without a nucleus that's enclosed in a membrane, or other organelles, have pretty rigid walls, Better example are exoskeletons, as in horseshoe crabs or snails. You can see why that is a very early attempt to separate self from non-self, to provide identity within as opposed to the hordes coming in from without. It's because when you rely on rigid walls like exoskeletons, they're very inflexible, and so the poor snail inside is really vulnerable while changing exoskeletons, right? If you have to, if the wall does get breached, then you become extremely vulnerable. So much more sophisticated, nature figured out, were flexible membranes. And it's interesting that as soon as the eukaryotes developed, these are multicellular entity. Ooh, wait a minute, I don't want to do that. Eukaryotes have flexible membranes, which means they are governed by interfaces. The membranes function as interfaces, and that is, there's one side of the membrane that faces out, the other side that faces in, and in a sense they follow rules or codes or as to what are you going to allow in, what's going to stay in, what gets converted into what, then what gets expelled as waste. So a flexible membrane, whether it be the skin or the eardrum, which is an example that Paul Cilliers used to like to use a lot. That's a lot more sophisticated a notion of an attractor boundary than is a rigid wall. When you think we have now come to understand that the skin isn't just an envelope. What are they calling it now? The integumentary system? That all these membranes, skin, and so on, they are active sites. They are dynamic attractors in and of themselves that are in the service of this translation between the inside and the outside. And so when you think of managing a complex system, you have to ask yourself, all right, What's going on at the interface with the public, with the context, with the environment, with the society in which this organization is operating, right? So they may be sharp discontinuities and rates and phases and cycles, as I said. For example, what's the only thing that differentiates, in a sense, a regular faculty member in an academic department and the dean? Well, the rates and phases and cycles that deans have to worry about are usually are annual. They are longer term. That is, they have to worry about the curriculum for next year in the department. They have to worry about hiring somebody in the budget for the next year in the department. Whereas the individual faculty member just has to worry about the class they're teaching that semester and the day tomorrow's class. Correct? So the boundary between a faculty member and a dean, or between the dean and the president of the university, is precisely the coordinating dynamic that all the constraintome is implementing at the interfaces. That's what a boundary should be considered. So flexible membranes are obviously much more sophisticated. Then you have gating constraints as boundaries. You know, like credentialing will institute a boundary that the person who does not have those credentials simply cannot get past. That is a boundary. They cannot get in. Some immigration systems like Canada use that kind of system. For example, they are point systems where if you have a college degree, you get so many points. If you speak the language, you get so many points. If you're a family, you get so many points, and so on. These are forms of boundaries. They are constraintomes that generate, constitute, maintain, govern the system that they are designed to hold together. So levels of organization indicate the presence of boundaries. Regulatory constraints are also temporal boundaries or windows of opportunity. We know, for example, that in a developing embryo or a developing child, there are certain constraints that have a window. And if those don't kick in at that point, if you lose that window of opportunity, they don't come back. So if you think of boundaries temporally, that just makes life even more complicated, because that means it's another completely different type of boundary that you have to concern yourself with. And these temporal boundaries can vary in scale dramatically. They can be evolutionarily established regulatory constraints that go back to the beginning of that species. They can be regulatory constraints of the system itself, the organism itself. I want to make sure I don't run out of time here. Talk about temporal constraints. I've got them here. All right, so I want to now take a look at one way to modulate oscillations and promote stability. May be, for example, if you can't change the attractor, so on, but you might be able to damp it somehow. And it's interesting how we talk about shock absorbers to refer to either automobiles or to the financial system, correct? Or carpetbags. So these are ways you can govern a complex system by adding dampers, and that promotes stability. If there is too much turbulence outside, then or the constraint regime is weak, then these dampers and buffers can help stabilize the system, because they do so by preventing the disruptive signals from entering the system. But once again, you've got to be careful, because dampers and buffers can make the system dependent on the buffers and the dampers, and so it cannot function without them, right? And they make them unresponsive to context. So buffers are different from dampers. Buffers are literally almost, the buffer zone between North and South Korea. They impede energy, information, resource flow. Sanctions politically are designed to serve as buffers. They impede energy, resource, or information flow, and therefore maintain the status quo, if you will. Buffers do not exist only in social systems. They obviously exist in chemistry. They exist in biology. That's what Darwin discovered the Pacific Ocean did. It served as a buffer, and it isolated the Galapagos Islands so that funny things happened. Once the buffer is such that nothing comes in and goes out, you end up having isolates happen. But I also, once again, want to point out buffers can be temporal. They don't necessarily have to be physical. So audio lag time, I don't know if Jocko's monitoring me and has an audio lag time just in case I say something outrageous and he can censor it. So at the limit, buffers and isolates can entrench differences, and as Darwin realized, they can lead to entirely new species occurring. So a problem with buffering, oh yes, you think you're stabilizing the system by adding buffers, but in fact you create isolates, and isolates mean almost, for all practical purposes, a closed system, which means it's going to devolve towards stasis and equilibrium, and it's going to not evolve. So I want to point out two types of entrenchment very quickly. One is natural entrenchment, and that is, sometimes nature discovers effective existing constraint regimes on its own, and that they are so effective that they tend to naturally entrench. Usually that means they are wide valleys because they allow sufficient available adjacent possibles to explore and to change. And so they can transition into a different attractor. So I think of natural entrenchment as sort of a natural validation of organically evolving constraints. But there can be deliberate entrenchment, and this, if you're thinking of social systems, there is deliberate entrenchment all over the place. And these are usually introduced to prolong, maintain, and clamp down on the status quo. You can either think of redlining for mortgages, waiting periods for new regs to activate. We saw a lot of these in the run-up to Dobbs when Roe v. Wade was still in place. There were all sorts of entrenchment about waiting periods before an abortion was performed, and so but some are not. I mean, again, governing constraints, constitutive constraints are stabilizing, and there's sometimes you need a certain level of entrenchment. You do not want a society where the Constitution is being changed every hour on the hour. But then the question is, when do you know that entrenchment in political systems has caused brittleness and lack of flexibility? Of course, the entire debate on the Electoral College here in the United States is an example of, well, is this being kept in place that way? And you always, of course, have unanticipated consequences of constraints all over the place that we could also talk about, that become entrenched even though they weren't intended to be such. So let me see. Governing control, ensure the runaway process don't occur. They are at the service of constitutive constraint. They're restrictive. All right. So in a sense, what I am pointing out is that you've got something you're looking at because something's gone wrong. You want to understand how it works and so on. Let's call that the focal layer of interest. But you've got to realize that the reason why there are complexity institutes like the Santa Fe Institute and textbooks about complexity, journals and podcasts like these, and even coaching in complex organization, is because getting a sense of this incredible interplay, and if you add time, of course, these things are constantly changing all the time as each constraint, as each agent acts. So you have a situation where you have a need for a general understanding of complexity theory, but you also need specific knowledge of the domain in question to really understand exactly which each of these constraints goes. So as I mentioned in the first book, I took the metaphor from Clifford Geertz about hermeneutics, about you're always tacking between the overall context and the local components to look and see how they each, and well, if I change the context, how will it change this? Well, the components change, how will it change this? If this changes altogether, how will it affect things? How would it change the topology of the entire system? And so what you have is, you know what, I think I'm going to skip this because otherwise I'm going to not be able to get to that example that I really liked. We've talked about this before. So, all right, so how do you improve adaptability? You enlarge adaptive space, you strengthen constraints, you lower the bulk. You might change the porosity. How porous is it? Change the gating at the interfaces and so on. Change the translation code of the interfaces and so on. So that's what you're looking at. But I came across that example of the Honeyguides and the honey bees, and I thought it was so fascinating because it illustrates all these constraints happening at the same time. Seems to me, can you see my screen now with the entire slide that Jocko helped me put together because I don't know how to do this prettily? Can you see it? Right. Let us suppose that you have certain context-independent constraints. And the context-independent constraints may be inherited evolutionary conditions. In this case, it was both the Yao tribe in northern Mozambique and the Hadza in northern Tanzania are familiar with stone tools. They have mastered fire and smoke to subdue the bees, open the nests, and expose the edible wax, right? The birds eat the wax, the humans eat the bees, eat the honey, all right? You have a background situation of a more fertile climate than the drier climate here that doesn't seem to affect things too much. Language is very different. The Hadza language apparently is one of a kind. It's an isolate. Whereas the language of the Yao is one of several Bantu, but that may or may not play into this dynamic as we will see. But then here's what's interesting. The economic conditions, which if you think about it, is one of these. One of these layers is just economics. Another one might be the climate. Another one might be the language. Another might, see? Right? So the Yao get most of their natural resources from farming and fishing. They do not hunt mammals, but they supplement their meals and their income by foraging for honey. Whereas the Hadza in northern Tanzania mainly live off honey gathering and hunting animals. So these don't hunt animals, these do. So as the Yao are looking for bees' nests, the Yao are very interested that in the process, they avoid scaring off. They want to make sure they scare off dangerous animals because these are the animals they will hunt and will eat. Whereas the Hadza, no, this is backwards. Sorry, this is backwards. The Hadza are interested in keeping the mammals around. The Mozambicans who do not hunt mammals don't care if they scare them off. And so what has happened is something very peculiar. What has happened is that there is a species of birds that are, if you look towards the bottom, their phenotype, they look exactly the same in northern Mozambique as in northern Tanzania. They look at their genotype has been sequenced, it is exactly the same in both cases, all right? They have developed an ability to guide human beings to where these nests might be in areas where humans don't usually travel to. So the birds are called honeyguides. I can't remember the Latin name, but they're called honeyguides, all right? And so what has happened, what has developed, what has evolved, is basically a culture whereby human beings signal, they emit a vocal sound that the birds are attuned to, and that they coordinate with the birds to get to the bees' nests, at which point then the human will use the fire, open up the nest, extract the honey, and leave the beeswax for the birds. But look what's interesting. In the case of the Yao in northern Mozambique, where they don't want these dangerous animals around, these large mammals around, they use distinctly human sounds. It sounds like, I wish I could have recorded it, I would have, but I didn't get around to it. It's like a loud, distinctly human trill followed by a grunt. And that sound will attract honey guides in that region. And the honey guide will skip and fly short distances while itself issuing its own distinctive honey guide call, and it will guide the human being to the nest. Here's what's interesting. The humans learn to do that from their elders. So it's a culturally learned human trait, right? In the case of the Hadza, on the other hand, who want to have the large mammal stay because they'll hunt them along the way. As they get the honey gathering, they will hunt the animals in the process. They make a sound that is very bird-like, and so it won't scare the mammals away because it sounds like it's just another bird. And so the mammal won't be frightened and will not leave. And so once again, young Hadza children learn from their elders to make these melodic whistle-like calls. Now what's fascinating is that the same genetically identical, phenotypically identical birds will learn to respond higher when they use these calls and when they use the calls in that particular location. Why? Because they will be able to find more. Because the overall system, the overall dynamic, the overall constraint is metastable. It produces more honey, more beeswax for everybody. And so the question is, do the birds learn this dialect? And the answer is no. What the birds inherit as propensities is they do all seem to be able to recognize distinct dialects. Other birds from other species are able to do that. But they both have a natural inclination to guide humans to nest. Even if you put fledglings in a different species nest, the honey guide within weeks of fledging will guide humans to nest. But the Yao will respond disproportionately to loud trills and grunts. The honey guides in this location will respond disproportionately to melodic whistles and guides. So the propensity to respond to particular and local calls is a constituting governing constraint that keeps the entire dynamic going. Now, what is threatening this constraint regime? Interestingly enough, the apiculture, the raising of bees, not just finding naturally occurring nests out there, urbanization, and therefore I would assume these two go together. The greater use of sugar instead of honey is starting to threaten this entire ecosystem, if you will. But I liked it because it really gives a very good sense of, once the coordination is established, it works as a constraint regime that preserves signal stability. So even if you try to introduce another signal, for example, that carries more, for example, the loud trill and grunt of the yowl doesn't carry as much as the whistle. So if you try to introduce the melodic whistle into the Mozambican ecosystem, it won't work. Once the coordination is established, it is a nicely entrenched, very sedimented, very strong constraint regime, because it preserves signal stability, and the payoffs are better than otherwise. So it makes for a very nice example of how all these constraints are operating simultaneously. You wouldn't think that economics, that hunting mammals would have anything to do with finding honey, because mammals don't produce honey. There's nothing that has nothing to do with it. And yet it's an economic contextual constraint that influences the actual sound of the signal that is produced, that will then be more likely to elicit a response from these birds, and everybody benefits. So anyway, that's what I wanted to end with. I'm sorry I ran over about 5 more minutes than I should have, but that's what I wanted to. Okay.
Well, first of all, Alicia, you can talk as long as you want. I'm just saying.
Well, no, I wanted to stop a bit earlier so that I could ask. I can stay here for a long time. I want to have people ask questions, but I just thought this example was unbelievable, because really it's a culture that has formed, interspecies culture between a bird, a mammal, and it's not even the same. What is it? Kingdom, phylum, class, order. It's not even the same. One is a mammal, one is not a mammal. It's different species, and yet there is an established constraint dynamic that got created. I loved it.
It was great. And for those of you, the article that Alicia is referencing, link is on the meetup page. I encourage all of you to check it out. It's very interesting. It's only about 5 pages. It's tiny type and it's double spaced, but we won't go into that. There's been a very active chat during this talk.
Oh my, I have
So I assume that many of you have questions. So I'll, and I think one question was answered. Kinsey, it seemed like your question was answered, but if it's not, just raise your hand and we'll go over it again. But I'm expecting all of you to join in here and give Alicia what she's asking for, a conversation. So who's up?
Please.
Let's go. Come on. I expect to see some hands raised. If not, I'll call on you. And nobody wants that.
How do I?
By the way, Daniel Susser, in the chat, you sort of said you're trying to get your head around all of this and figured out how you can use it. Well, welcome to the club, my friend. That's why we're all here. And that's why we continue to do this. So, Bernhard, you had a lot going on in the chat. Do you have anything that you'd like to share with Alicia? Is he still here? I don't think so.
Yes, I am, but
there you are.
Yeah, it's so I'm browsing through my to find the own things that I posted because I got lost. I think, Alicia, you always when you talk, it's like a rocket flying and it leaves stuff left behind. And then you take a detour tour as a listener,
Yes,
and then you're
yes.
obviously, oh, where has she gone in the meantime? And for me, it was a bit a trip like that. So actually, for the moment, well, there is maybe one thing, because I was constantly, I mean, you were very consciously keeping it, with the exception of this last example that you deep dived into, but you were keeping it on abstract terms that can be, as is the case with complexity size, applied to many different kinds and types of complex systems. I was wondering if we focus ourselves on social systems. This whole thing about constraints forming out of the interaction of elements in the system and then having in a way a feedback back into the system. And by the way, that picture that you constantly pointed to, I think there is one thing that is, at least to my view, not very helpful, which is that these lines that are represent the concept, they are fixed at the bottom in
Absolutely,
these
exactly,
big black
exactly.
points.
Yeah.
They should be connected to each other.
Absolutely, absolutely, absolutely. And
yeah, so but that's just in parentheses.
It looks very much like a puppeteer, and it shouldn't be.
It assumes that there is this ground level, which again is independent of the system. But when you take this into the social system, then I was very much thinking of symbolic interactionism. So this whole Blumer, Goffman, and so on, this idea of things like I don't know, the politician talks to his audience in a way that he thinks, so he has a lot of representations of what this audience would be based on his prior reactions that he could see. And then the audience, of course, gives a certain identity to these politicians, which again primes the reactions of the other. Would this be like an application of these different exercises of various types of constraining and buffering and so on that you went through?
And the language that is used has resonances to subcultures that might make it sound innocuous to the general public, but to the subcultures in the know, those particular terms have particular meanings. And oftentimes, though, that language is used very deliberately to as trigger points, as very much so. And I think we are now much more aware of the backstory than we used to be. I think.
What do you mean by backstory?
I think people used to take what was said at face value. But now we're looking for all these constraints and interplays and what's happened. And I have had 10-year-old children tell me, well, yeah, but what's the backstory to that event that happened? And wait, what? How would it would never have occurred to me that that it should not be taken, that there are many more layers of these constraints, going back in time, going back, how broad they are across different subcultures. And now with memes, with references to influencers, to all these things are playing out at the same time. I don't think we're anywhere near close understanding how to map these dynamics at all. And yet, these are what are affecting the surface phenomena. Absolutely. And again, it's climate, evolutionary background, language, economics. It's all playing out. In this case, it was bird calls and so on, but it's similar. But yet we belong to so many more constraintomes than just one. People talk, oh, my identity. What does that mean? We're all such multiple constraintomes that manifest or not depending on the environment, will amplify it or not, or block it off or not. And so we have to keep all of these in mind. It's difficult.
Oh, yeah. Okay, we got some hands up. All right, so Juno, you had your hand up first.
Yeah, hi. Thank you so much, Alicia. Just briefly, I wanted to share from the images that you shared of the Waddington fitness landscape. There was this idea of talking about a fitness seascape introduced by H.J. Merrill in epigenetics in a book by the same name, I think, from the 90s. And that was a good way of kind of like flipping the narrative, because of course, like, landscapes change, but over very slow time scales, and it's much easier for us to think of landscapes as a static thing. But seascapes change over the period of time that looks very like dynamic to our human time scale.
Absolutely, absolutely. And I think that's what Dave Snowden has in mind with the whole estuary mapping, and that is that the sides of the estuary change along with the changing tide coming in or going out, along changing with the human who break up the estuary sides. And so that's exactly what we're all, I think, trying to get at, is this notion that the enabling constraints that generate these coherent dynamics in turn can get destabilized or modified or adapted or evolved depending on other constraints coming in. And so it's all being implemented at the same time. And yeah, that's a good point. I'd forgotten about that seascape example.
Okay, thanks, Juno. Johan?
Yeah, thank you. Thanks, Alicia. I'm trying to follow you now, so I just need to try out something on you. You talked about oscillation, and also wild oscillation could threaten attractors. But also, if something doesn't oscillate, it becomes some sediment, I guess. So it's something living in it. And you talked about timing as well. So the thing I maybe missed there is about coherence. So oscillation with coherence, that could be strengthening the attractor instead of threatening it.
Correct. If it becomes so sedimented and so set in its ways that it starts, that the process continues regardless of what else is going on in the environment and the context, then what happens, it seems to me, is that you lose the responsiveness to context, and then it becomes an entrenched dynamic that is not fit for purpose. So it's a tricky situation to maintain stability and have it stabilize and sediment. You can't have language only with metaphors. At some point, the metaphor has to sediment as established, defined meaning, so that then you have another stable point on which to riff later on in the future. But how long that stability remains depends on its components, the context in which it exists. So yes, you're absolutely right. You want the system to be dynamic, but you don't want it to be spinning. I guess the word we would use is it's spinning its wheels. It's not going. It's not getting traction because it lost contact with the ground, with the environment. Yeah, that's, I think, the way to answer it.
Great, thanks.
Yeah, I like that, Alicia. It's a good one. Randall.
Yeah, sorry about my video. It looks a bit weird. I'll show you. There I am.
Yeah.
So I'll try to fix that.
You look very handsome.
Thank you. Very feeling blue today.
He is not a cat.
So two questions, Alicia. One is, my background, I kind of came up through perhaps many, like many folks on this call, through sort of a systems thinking background. And so a tool that I have used and still use is this notion of an iceberg diagram of events, patterns, and structure. And my first question is this: when I think of constraints, I'm almost equating it to structure, both internal and external structure. And I was wondering if that's sort of a valid way to think about constraints, is that it, like in an organization, structure obviously manifests in patterns which we see on the surface of life. And so it seems to me that, constraints is just an example of both either internal or external structure. So that's sort of one question. The other question I had real quick is with regards to phase shifts and creating governing constraints. And the question is, can we know when phase shifts are occurring? Again, sort of within organizational setting. Are there sort of indicators that would tell us if you're sort of the facilitator enabling, that you've created this sort of these set of enabling constraints to create a phase shift? Can you know, as sort of the architect of it all, when that's going to happen, or is that just or is it is there just so much uncertainty that you could never really know when the phase shift itself is going to occur?
That's a tough one. My instinct is to say that yes, I would think of a structure as the embodiment of all the constraints working together. So yes, I would say that they are two sides of the same coin, if you will. What I would feel a little bit uncomfortable with is architect of the whole process. I think that is a difficult thing to do with a complex system. I think it's easy to tell when the existing constraint regime is at a threshold of instability. And I think the examples I gave were wild oscillations, wild variability, and we see that with climate change. People thought, oh, look, it's colder than ever. What do you mean global warming? Well, what they didn't understand is that climate change is extremes in the fluctuations, is an example of this is a system that's at its threshold of instability. Now, whether the system is still sufficiently strong to dampen all those fluctuations, and then have it, well, we thought there was going to be a revolution, but there really wasn't, or whether it will amplify these perturbations and tip it over into a new phase. And we've got to remember, complex systems don't promise you a rose garden. The system can literally fall apart. There's no the next phase might simply be literal chaos, not chaotic dynamics, which are just very sophisticated forms of order. Literal chaos. I mean, the Roman Empire did fall in a sense. You get a whole different constraint regime that got set up after Rome and Constantinople were not able to hold the center. The center doesn't hold, kind of a thing. So I don't know to what I'm not even sure we can know when the phase shift is over. Well, when things start to stabilize again after a phase transition, it would seem to me that the ChatGPT has introduced the potential for a very significant phase shift, kind of like comparable to the introduction of the internet and the web. But it's really hard. It's really hard to tell. There, you go back in history, there are cases when things then just, petered out and everything settled back to what it was. It's very hard to know ahead of it. Sometimes it's easier to tell in retrospect, but not ahead of time. We can amplify fluctuations that we hope will guide the system towards a phase shift in a better direction. amplifying existing fluctuations, suddenly an existing fluctuation being a little enabling constraint that sort of pops up here and there. And I'm definitely thinking social systems here.
Right. And so on that, I mean, is it you earlier you were talking about this idea? What I had heard is that to use the word architect might be wrong-headed. But when I'm trying to solve complex adaptive challenges in my contexts, I do think of myself as an architect in the sense that I'm stringing together a set of enabling constraints that can force a phase shift in a direction that I'm looking for, or that, let's say, leadership's looking for. So in that regard, I think of myself as an architect doing that. And then what would be interesting, maybe as a follow-on book, is this idea of the art and science of stringing together constraints to create, the world that you want to see.
In other words, you would think, because I usually use the word catalyst for that, but I think you're using the term catalyst more, architect more as the selection of the catalysts, the grouping of the catalysts, the timing of the catalysts.
That's right.
See, though, so that would be more almost like a meta governing constraints. Can we do this? What would have served that purpose in this example I gave before? The terrain, maybe? Does the terrain serve as the architect for, or are some of these acceptations just happenstance that, they got lucky. Somebody whistled and there happened to be a honeyguide bird in the neighborhood, and that one that was attracted to that particular whistle, and it started, how does a culture get going? How does a culture coalesce is basically what you're asking. And how do you get it to transition to a new mode of organization? I mean, look what happened in the Industrial Revolution. The initial reaction were the Luddites, right? To break all the machines. Correct? Because these machines were the enabling constraints that were going to lead to an entirely new dynamic between workers and labor capital, everything, right? That was the initial reaction. It took a while before the whole thing transitioned.
Thank you.
I don't know if I answered the question. It's hard to answer.
Okay. All right. Hopefully that was good. Randall, you okay? All right.
All
Shasta.
good. Thank you.
Shasta.
Yeah, I think this might be a continuation a bit of that conversation too. So maybe there'll be more answers in the discussion. I had wrote it down in the chat just so it was in when it came to me, and it was when you were talking about even the 10-year-old is asking what's the backstory and stuff, and it made me, the way you were kind of talking about it and the way that it's kind of continued in the discussion since that was a few people ago. I'm wondering, it's almost are you almost using constraints or constraint regimes interchangeable with the systems, like what we might have just said, oh, that's that system, oh, you got your electrical system in your car and your and your gas system in the car, and then but those are two different constraint regimes. So yeah, I don't know. Are they the same?
I think there are nested layers of constraint regimes. And so what the manager who's looking at the overall picture has to do is make sure they all coordinate with each other. Correct? And
yeah. So are you almost saying system is just the general word, and then the atoms of the system are the constraint regime?
Yeah, except that you have a lot of different layers. So you have organism, but then you've got organ systems like the digestive system or the nervous system. But then you've got the tissues of the stomach or the tissues of the liver, correct? And the tissues are systemic set of constraints, and they differ from the other tissues, and they differ from the cells that make up those tissues, right? So you've got layers of organization. In the case of the 10-year-old, what as I remember, people were talking about poles and polling. And the question is, yeah, but if you tell the backstory, the people being polled know that their answers are going to be publicized, and that's going to affect other people. And so they're not giving a straight answer. They are being constrained by their understanding of a constraint regime that's about 3 levels away from them. If you get my drift, the fact that people understand what a bandwagon mindset is, and that once the bandwagon starts, it's very hard to hold together. And so the more people say yes, that they are voting for X, and the more it will tend to accelerate. And so they will modify their answer, not because that's what they really intend to do or believe they would like to do, but in order to try to affect a higher level constraint dynamic, if you will. That's the kind of backstory that I think this child had in mind. I said, gee, it never, are you for so-and-so or against so-and-so? The answer would have been very straightforward before. Now they're looking at all these different layers before they even think to speak.
I just like that it's an interesting, another way of talking about things to talk about constraints, because I think even system, we're getting very confused sometimes in like how it just in the some of the events here that I've come to, there's a lot of debate in like what we call it and stuff. And when you were talking with somebody else about like social systems, and like some people also have a hard time seeing like all the different social systems and how things got to be. But I wonder if like constraint is almost feels like a more understandable term.
I don't know. I've gotten
maybe
because I think the negative side of that is that in the vernacular, the word constraint always means restrict.
Oh, yeah.
Whereas I tend to use it the way the biologists use it, to include constraints that open up possibility. In other words, you have certain interactions that open up other possibilities as opposed to closing off possibilities. And I think that's important because we never look at that. What the biologists were the ones that were most early aware of this, I think. And that's why reductionism never went as far in biology as it did in other disciplines, because they understood the role of oxygen as an enabling constraint, right? And that its creation through cyanobacteria was a big change in the possibility space that it opened up, correct? The appearance of oxygen in the biosphere changed everything. As did eukaryotes, the fact that you now have multicellular organisms. It just opened language, and for Bernard, who was asking about language, our ability to use symbolic language opens up possibilities. I think a system is by definition multiply realizable. In other words, a system is a coordinating constraint regime that holds a lot of different instantiations and events under one dynamic, so that the more open that system is, the more likely it is to evolve. I didn't talk about, when I said generative constraints, what biology seems to have figured out, and the cosmos in general, because it happens in several places, and that is, you start out with fairly rigid constraints because you want to make sure if you will, the Bauhaus, in the case of an organism, the body plan is faithful, and you've got 2 eyes in the front, 1 nose, so you've got the bow plan. It's fairly rigid, but that's early on in the embryonic development. But it's you want to make sure the infant has certain basic things that they can do, stereoscopic vision. You want to make sure those constraints are rigid enough. But then you want to make sure that you can loosen those constraints so that then the individual embryo, or even identical twins are not exactly identical. And individual children obviously are not from the same parents. So you want to make sure that the individual can find different viable, coherent dynamic within the overall structure. So this idea of having constraints that kick in differently at different times, and that at each point you're closing off what you don't want and you're opening up what you might want. That is an incredibly new form of constraint than, say, the prokaryotes who only had the wall around them. It's a lot more sophisticated.
Yeah.
Okay.
Thank you.
You good? You good, Shasta?
Yeah.
Okay.
Yeah. Thank you. Thank you so
Okay.
much for
Yeah,
talking
and
to us today.
this question, before we go to Michael, this question of language and the use, I mean, there was a lot in the chat about attractors, and those of you that were involved in that conversation were at pains to say that we're using the term in this sense, and the term attractor. Alicia is using the term constraint in this sense. And that's really important, I think, when we're talking about this, because in the literature, as you read more broadly about all of these things, you find these terms used in a slightly different fashion. And, or somebody defines it in a different way. And you just have to be aware all the time when, for example, we're in this meetup and Alicia is speaking, the word constraint is being used in this fashion. The word attractor is being used in this fashion. And then you go out into the wild and somebody's going to use, Dave Snowden might use constraint in a completely different way, or a slightly different way. And you just have to sort of roll with it and understand that these things are not rigid in that sense. Is that a fair thing to say, Alicia?
Absolutely. I think of an attractor as a zone of stability that interactions tend to gravitate towards because it is more stable.
Mm-hmm.
So I want to cash it out in thermodynamic terms in that sense. It's the reason why this culture between the humans in Africa and the birds has become a system, and it's an attractor, is because it is more stable as a coordination phenomenon than if the individuals were to try to find the bees' nests on their own, and if the honey guides tried to, when they found the bees' nests, they couldn't break open the nest and they would get stung by the bees and so on and so forth. So the birds obviously don't have the access to the smoke. So the dynamic as a whole is more stable and produces superior, more effective outcome, right? Evolutionarily, right? The honeybees can reproduce more and faster because they are more nourished. The human beings can too. So it fits the Darwinian notion of selection. But it's cultural selection. It's cultural selection. Selection by culture, which has been questioned by a lot of people, but I think more and more people are coming to the conclusion that yes, there is such a thing as cultural selection. And then my question is, what holds that culture together? And the answer is all these different constraints, right? Some of which are enabling, the fact that humans can use stone tools, the fact that they can use fire, know how to manipulate it and create smoke. The fact that these birds have evolved some kind of flexible ability to understand variations in calls and so on. And so all of these together created this ecosystem that I would call a culture.
Okay, So Michael, you've been very patient. Michael has his hand up. Go.
Hi, Alicia. Thanks, Barbara. I've been recently had a chance to start diving into your latest book, and I decided to read the concluding, sort of your final chapter 16, which is your concluding remarks, and I found it incredibly well summarized and dense. So there's loads of information there, and the summary statements are incredible. One kind of caught my eye amongst a lot of them, and let me just read it out, and then I'll ask a question about it. You said that epistemically and politically, keeping the conversation going, with reference to Rorty 1982, keeping the conversation going is a validated enabling constraint that contributes to metastability. And I was kind of reflecting on that. If from your perspective, what are the risks and opportunities or related to under-regulating, over-regulating, or controlling the conversation vis-a-vis perhaps a corporate communication context, even perhaps across, information landscape geopolitically?
Yeah. You can see where I'm coming from as to why I say that. I think I'm going to answer your question. Bombardigiani, who's a historian of science, but he's also a historian of the American Constitution. And if anybody's interested in this very long paper about the American Constitution, I'm happy to direct you to, I can find it for you. Bombardigiani argues that the reason why the American experiment has been so successful is because the American Constitution, unlike many other constitutions in the world, simply specify the syntax of the country. It lays out the rules for making rules and the rules for amending rules. It doesn't specify much what those rules have to be about. So certainly, in order to keep the conversation going, there have to be certain governing constraints about the syntax. And everybody is using the language in logic we call it well-formed formulas. The syntax has to be well-formed. There are actions that go beyond that syntax, that break that syntax, in which case you are acting unconstitutionally, correct? Within those constraints, then, the system can change. I remember when I came to the United States and I lived in Florida, there were bathrooms that said white and black. My father sat in the back of the bus, and my father sat in the front of the bus, and he got up because a black woman came in, and he went to the back of the bus, and the bus driver told him he couldn't do that, and he said, I'm going to do that anyway. But those existed still, and in 50 years, that changed. I think of the conversation not continuing in that I have friends here who are Vietnamese. Americans lost 57,000 Americans in Vietnam, and Vietnamese go back and forth, and there's business going on. And I'm from Cuba originally, and the constraint regime in Miami is such that there has been no conversation going for the last 63 years. Correct? So I think you need a syntax to keep the conversation going and seeing if you can find middle. In Spanish, the word, you shouldn't have asked me this, Michael. In Spanish, the word compromise does not exist in its positive connotation. That is bad. It means compromise as in you compromise your principles, which is a negative. But the fact that we reached a compromise, and that's a good thing, or as a phrase that I love in Americans that say, I can live with that. I don't much like it, but I can live with it. That is, I guess that is, what's the minimum, and that's why it's from Rawls, because Rawls says, what's the minimum requirement that any human being needs to have a dignified human life, correct? And then once you've got certain basic syntax and semantics going, then the question of how you modify it and how you can move it along, it gets affected, gets changed. I don't know. It's a hard question. It's a very hard question, but we'd better figure it out.
Yeah, and I think in the corporate realm, what I'm seeing with the narrative work I've done is oftentimes sort of the bottom-up perspectives and concerns or reflections on the nature, the way communications across the enterprise
Correct.
is aggressively controlled and managed, actually has a significant negative reaction that oftentimes completely disconnects a leadership team from the attitudes and perceptions at the front line. So I thought that I got to unpack that much more, so that one line as amongst many in your book, because I think there's something there that argues that, even if the dialogue is tense and difficult, right, we have to keep the conversation going.
But again, you have certain, as to how that conversation the syntax of that conversation is to proceed so that it can keep going. Otherwise, it degenerates into a brawl, right?
Yeah.
Which is exactly what you don't want. And it's a difficult, I don't know how to articulate it. So once you guys figure it out, then you can write that book about the art and science.
Thanks for the response.
Yeah.
Okay, any other hands up before I start calling on people? Greg is raising his actual hand. So, Greg.
I was just thinking about the mention of habits earlier, and I was thinking of Toffler's statement about the 21st century will be about unlearning to learn. That we actually have to probably learn that as a capability to enable us to get actually out of this.
Right. And the whole problems with pedagogy, just open up all the way here. How do you set up an educational system that is inclusive, meaning you're educating everybody? We kind of know, and we did it for a long time, how to educate an elite few, right? And that tells you how exactly the disconnect between them and the people they were governing, right? And so on. But we don't know how to educate and create coherence in such an incredibly disparate set of elements. And I think Montgomery County, Maryland, which is down the street here, adjoins the District of Columbia. I think there are 147 different languages spoken in the in homes of kids in the elementary schools in Montgomery County. 148. Some of which are cultures that are not literate culture. They have no written language. How do you create a society that enables this to work and maintain its goal? No, one thing we know about complexity is fused blocks are not complex. The idea of a complex dynamical system is that these layers maintain their integrity, that the individual maintains its integrity, even because that enables it to participate in a lot of different constraint dynamics. The idea is not for the individual element to fuse into a block whole. That is dictatorship, that is authoritarian, that is certainly not the way evolution works. Evolution maintains the mitochondria are still mitochondria inside the cell, correct? They don't fuse into the general whole. And so how do we learn to keep, and I think the key is in the interfaces. The key is in the flexibility of the interfaces. How does the language open up to the environment and communicate information with the inside and keep the stability within bounds?
Yes, we've touched on, you could think about the cell boundary.
Exactly, exactly. We have to imitate the fact that the cell is an active site. It's not an envelope. It is an active system. It is an active complex system. And how it navigates the relationships between the inside and the outside. And what seems to be the case is that the universe seems to be going more and more to context-dependent navigational codes, if you will. So the book learning we all learn, hey, this is what happens. This is what you're supposed to do. That's it. It's a check-off table, right? It's a matrix. That's it. That there are too many variables. You cannot do that. So you need judgment. So the question is, how do you develop judgment? Judgment is a balancing act. It's an adjusting act. It's a fitting together of all these disparate things into a messy but internally coherent, logically coherent system.
But what we need to do is maintain the diversity. That was Noble's point, is you're going for an outcome, the genetic model. That's effectively lost. It will take them 10 years to rebuild that capability in the medical environment. We've seen that just so many times as well.
Okay. And does anyone else, listen, the chat was very active, so I know some of you have questions. So Mark, you were very active in the chat. Is there anything coming out of this that you'd like to comment on?
I think Mark's just dropped in.
No, here he is.
Oh, sorry, apologies.
Well, I just responded to things in the chat.
But and coming out of that, what do you see as like the things that we really need to focus on in the sort of explanatory field in this? Like, this question of language, you were very active with that. You were sort of trying to come to terms with what attractor means in this sense. And I feel like there's a lot of work to be done around this area of like defining our terminology in a way that is consistent or at least coherent.
Yeah.
Okay, you give me far too big a scope to answer, but maybe just sharing a little bit my experience trying to use this language. And so my first recommendation is do not. So here's the first thing I learned. The only people you can talk about complexity in these terms with are people who are engaged in these kind of conversations already. And that requires that they had multiple experience of complexity and acknowledge it exists and it's a thing and we need to cope with it. Outside, so when I talk to people at work, I completely stop talking about it. Some people have brocked that earlier. So there's Matt Barkram who said, never talk about Cynefin. So, and he's right. So once people understand the phenomenon of complexity, then some of this language is helpful. But this is also a complex field. So I don't think there ever will be a clear, so in the sense of context-free way of using this language. Mm-hmm. So even the language has to be adapted to the context that you talk to. But if I can close with one small hint. So I discovered, thanks to Jabe Bloom, practice theory about 2 years ago, or maybe 3 years ago. And again, do not talk to people about practice theory. In general, all these theories are for people who understand the problem at least already. But how do you deal with complex problems in a work field? What practice theory says is follow what people are doing, not who they are, not what they're saying in conversation with one another, but not their values, principles, their individualism that they bring in. And this is why I made that comment in the text. We have to get away from individualism. So what practice language or the practice lens or the practice turn, as they say, allows you to do is literally start looking at what happens and how things that happens, things that people do outside constraints like regulation and blah, blah, how they interact with the work. And then you find actually quite quickly things that are actionable. The big advantage talking about what people are doing in terms of practices is as practitioners, they are vessels, they're not originators. So they can't be, you can't blame a developer for doing TDD, yeah? Because any developer that does TDD didn't invent TDD. It's a practice that's shared among lots of individuals. And once people start to study TDD, they will see other different schools of thought in TDD. There's not just one thing in TDD. And so by talking about what people are doing and connecting what they're doing, you can bring the context in without ever actually, so the blame game disappears. So I don't know whether that answered or was helpful in terms of your question, Barbara. I'll leave it at that.
Well, no, it summarized a lot of what was going on in the chat, and I appreciate that. So thank you. Alicia, I don't know if you have anything to say about that, but it was interesting.
Yeah, practice is a tradition that you are entrained into, correct? And that then you are aligned with certain practice, certain ways of doing things and ways of speaking. And I think that's the definition of being inside an attractor, inside a system, that it entrains the behavior, the language, the possibilities, the dynamics of participants in it.
Okay. Adam, you've been super active in the chat. Do you have anything to add to the conversation, or do you just want to lurk for a while?
Just lurking and bloviating. Thanks for having me.
No, I mean, it was a super interesting thread. I was in and out because I was trying to answer questions and things, but there was a lot going on in there.
It's just the same stuff that Mark's kind of alluding to. It seems like authoritarianism gets very much in the way of doing a lot of these things, much less talking about these things. There's a lot of very linear deterministic thinking and at least technology executive leadership that I've encountered, where it's just a lot of like, you come across as like, those aliens in the comics, like the guy made where they say funny things like, I'm going to go get my mouth stones cleaned kind of thing. And they're trying to observe things. I feel like that's what complexity minded people sound like to sociopathic deterministic executives who are like, oh, the problem is that guy's an asshole. And you're like, well, wait, but what like guiding constraints are causing this? And what kind of constraints could we apply? And they're like, what's wrong with you, you idiot? I told you the problem, that guy sucks. And so it's very difficult to like get people to get on board with this stuff, hence Barkham's law. Like you can't talk about that stuff at all. You just have to hope you can find a way in to say, well, maybe we could try something like this, and not immediately get laughed out of the room.
I'll usually look for an example when they bring it up themselves, and then I'll jump on it and expand it. That's my trick. If it's coming from you, they won't listen to it. If it comes from themselves or somebody near them, you've got to crack and you got to exploit it quick.
Absolutely.
Amplify fluctuations that happen to change.
Yeah.
So Barbara, Dan had his hand up earlier.
Oh, Dan, yeah, hands are up, hands are down. Dan.
Yeah, you were talking about sedimentary constraints, and that had me thinking about language and terms as an example. What are your thoughts on that?
Oh, somebody said dictionary definitions are sedimented metaphors. A metaphor is sort of a wild connection of different things, and then, but if it resonates with others, and resonating is one way that coherence gets created, correct? Then it becomes sedimented, and then one forgets that it was metaphorically originally, and now it becomes dictionary definition. And so I think language does that a lot. And curiously enough, it does that locally a lot. Dialects pop up in amazingly small locales But that seemed to, and not to mention age groups, you can do that too, you know, teen speak. Even the 17-year-olds don't understand the 13-year-olds, right? I mean, talk about, yet they all understand it because it's sedimented within that population momentarily.
Yeah, the language stuff is complex in and of itself because of that locality, the that sediment level. But it is difficult for us as an individual when we have the same term being used differently in different contexts or in different fields. But for the field itself, in a broader sense, it's extremely healthy. And once it actually gets locked in, that's a sign that it can't change anymore, right?
Absolutely. Ambiguity is a good thing for the system because it gives you that slack, that sloppy fitness space, that room to maneuver. That's where Bertrand Russell and Alfred Lord Whitehead went crazy with Principia Mathematica. That's what they screwed up. They thought they could turn all of language into syntactical, logical, mathematical structure. And that's what they realized. What's the story about Wittgenstein finally decided he wasn't going to follow that when after the First World War, apparently he thought logic pictured the entire universe. And there are two stories, either Ray Monk, a colleague, or his Italian gardener went to him and went, and tell me, how do you logically map that? And what does that mean? And the powerful story is that that's what changed Wittgenstein's mind. Yeah, or this one, or whichever it was, one of these.
Map that. Put that in your pipe and smoke it.
Totally culturally conditional. Totally culturally conditional.
Yeah, the language thing, which really quick, on the language thing, it's really frustrating because individually for the agent's point of view, it's very frustrating. But again, for the health of the system, it's very, very healthy. Michael, sorry.
Yes, just quickly, I wanted to interject. Isn't that fundamentally going to be the ultimate challenge of AI and large language models?
Absolutely. Yeah. It does not switch context easily.
Yeah.
So the question is, once you introduce sensory information, vision, hearing, so will the different modalities somehow cause that to emerge? That's the question, because at this point, it does not switch context easily. That's the main problem.
Okay, we have a couple more hands up. Shin, am I pronouncing your name correctly?
Yeah.
Okay.
Are you able to hear me?
Yeah, we can hear you.
Okay, I have been thinking a lot about how to phrase what I want to say, but in many ways, I think I want to thank Alicia for a very liberating presentation or talk, because in my in my head, I've been struggling with the how different or similar are systems thinking and complexity theory. And I think maybe Dave Snowden would be pretty mad at me when I say that after this talk, I see a pretty big like coherence between these things, because it dawned on me that maybe this is just very obvious for a lot of people here, but I'm not very experienced in this field. So I'm just thinking the word system itself, it actually basically speaks to, there's a rhythm, there's a beat in it, there's a stabilizing thing in it, and call it constitutive constraints and call it governing constraints. It's these things that what makes a system. But then if we over constrain the system, then we see these monoculture, then we see these bad things happening. So in a way, I feel that complexity theory is basically no, not complexity theory. The what Alicia is talking about to me is sort of trying a good sort of a mesh for acknowledging the system as a system, because otherwise, like Alicia said, it's gonna there's no identity. The stabilities is what gives something an identity, but then at the same time, I just feel that there's this emergent and unpredictable thing that needs to be there. We need to design for it. So my question for Alicia, sorry for the long rant, it's more like, I'm an architect in the software space. I consider myself a socio-technical architect. I'm still hopeful that this whole thing can be designed for. I second what Mark is saying, like all these big theories and abstractions is not like for mortals. Like people tend to, get very frightened about these talk. But can't we do a kind of a, combination between designing for these APIs and relations that liberates, and at the same time creating these conditions for that emergent conversations to occur. For instance, visualization, for instance, collaborative modeling, for instance, a conversation that people can, chip in with the variations of whatever varieties. I'm just still probing on the architectability part, and I want to hear more about the, is it really so bad that we can't really design for it at all?
In another incarnation, I'd love to be an architect. But for example, I think architecture in the West has forgotten about context a lot, meaning they have forgotten about climate. And therefore, the structures that are built in a desert, hot, dry, arid climate, and the structures that are built in the tropics look exactly alike, and they all rely on air conditioning and so on. They forget about the thickness of the walls and so on. So if you start bringing back context into architecture, oh my goodness, there's a huge potential, I think, there. And the other aspect, one example I loved, and that was, I can't remember who the architect was. It was an office building, but then he left the walkways to the parking lot without design, because he wanted to see what the shortcuts were that people naturally took to get to the bus or to the parking lot where their car was or whatever, or the trail to walk home. And so it was after those paths had already been blazed by people that then he inserted those from the parking lot to the building. I think that's an example of taking context seriously and having the use provide the enabling constraint, and the context providing the enabling constraint. I think there's an incredible amount that can be done in architecture for climate and so on.
Thank you so much. That makes me hopeful.
No, I love that. Yeah.
Bernard.
Yeah, thank you. I want to come back to this notion of ambiguity in meaning and the language, because I thought the discussion in a moment would invite, I had the impression at least, it sounded a bit binary. We either mean the same thing with a certain word or we don't. And I think it's more helpful to look at it in relative terms. And if we do so, then, there is a certain degree of common understanding, even if it goes with the illusion that we have full common understanding. We need it to a certain degree, otherwise it doesn't work. So ambiguity is helpful at the fringes. If it becomes, very widespread, if it becomes dominant, I believe then conversation breaks down.
That's why I was careful to say that, like, we try to define things in the context of this meetup. Right? In the context of this meetup, we're using the word attractor this way. Outside of this, when I'm talking to someone else in a different field or something like that, the word attractor may be used in a completely different context. And my point only was that you need to be sensitive to that you are using language within a certain context always. And that for the purpose of this meetup, we try to be sort of definitional, and as you say, at the edges, we allow for ambiguity. But I think that the language problem is one that's going to haunt us for a really long time. You know, it's just, I think it's just baked in at this point.
See, in philosophy, the terms are vagueness and ambiguity. Ambiguity is two different meanings for the same term. Like blue can either mean depression or it can mean a color. So but it's very interesting to have ambiguity because you can make then all sorts of different connections that you wouldn't think of. It supports metaphor and so on. Vagueness is different. And in fact, the word blue is not only ambiguous, it's also vague, because there might be an exemplar for blue, but then where does it shade into turquoise and where does it shade into purple, right? Or baldness. There might be a central exemplar for a bald person, but where do the edges, where do you stop using the term balding? You say balding, but not so bald. Then how do you make that distinction? So
the visual, Adam.
Yeah, we saw that. Very good. So I think there's a reason why language has become vague and ambiguous, because it really supports flexibility. And that's also the reason why emails required, sooner or later, somebody had to invent emojis, because otherwise you wouldn't be able to detect irony and humor and so on without the little emoji. You might be insulted otherwise. Whereas the tone of voice, we have evolved to be able to understand that if you're in that culture. So yeah, no, language is a messy, difficult situation. You're muted. You're muted.
You're muted, Barbara. But while we're waiting for it comes to mind that punctuation in chat now is now considered rude. So anyways, Barbara, go ahead. Okay,
I was just going to say we've kept Alicia well past the hour. So if there are any other questions, speak now.
Thank you. Thank you for having me.
Is that it? Otherwise, Alicia, as always, this is amazing. You can come back whenever you want.
Thank you so much. Thank you so much. I mean,
we already had requests in the chat for like a follow-up session, so that tells
not complexity light.
Yeah,
I'm not reading this book until you come out with complexity for light.
Yeah, Alicia's next talk will be simplifying complexity.
My favorite title of all time.
That's right.
The complexity cookbook.
That's right.
Oh, there you go.
Recipes.
101 recipes.
Complexity.
Yeah. Recipes. That's right.
Well, you know,
thank you so much.
I encourage all of you to buy her book or find her book. Alicia, do you want to tell us a little bit about your book? Context changes or?
Well, it's just that science forgot context a long time ago, starting with Galileo, who said things like, well, you can forget about friction, you know. Our idealized models work fine. And it did for a long time with a lot of things, but even Newton knew if you brought in the third planet, everything got screwed up, right? Couldn't do it. So my idea was to bring context in, but since that wasn't going to work with the word, talk about language, the word cause wasn't going to work, then I decided to use the word constraint going back a long time ago. And so this is more of an exploration of the notion of what brings about what. That isn't just billiard balls pushing into each other. That's what the book is about. So that's why buffers and scaffolds and templates and that kind of enabling constraints or stabilizing constraints. That's what it's all about. It's about this stuff.
You know, and if you want to see how Alicia brings to bear all of the stuff that she's been talking about, I urge you to check out her company, Vector Analytica, which, you know, does some great work, but you can visit the website and find out about that. For all of you, thank you so much for coming. Thank you so much for hanging with us. If this is your first meetup with us, I hope you come back for more. Our guests are not always like Alicia, but we think they're all very interesting.
Clearer. They're clearer. Thank you.
Don't bet on it.
Thank you so much.
And for those of you that are regulars, thank you so much for coming back, and we hope to see you all soon. We have some great guests coming up. Thanks, everyone.
Thank you. Thank you.
Thanks for making it happen, Barbara. Good to see you again, Alicia.
Thank you.